All right, let's go over solving some proportions that actually deal with algebraic expressions. So kind of a little bit more complicated proportions than maybe you've done before. But first, let's go back to the simple ones. What is a proportion? Again, um, proportion is an equation of two ratios which have the same value. So, um, my example. Three. So these are ratios. 3 to 4. That's a ratio. You're just comparing two numbers. 3 to 4 is equivalent to 6 to 8. And if you want to test that, if that doesn't jump out at you as being obviously true, just get the decimal equivalent to both. If you take a calculator and divide 3 divided by 4, which is what that fraction is saying, 3 divided by 4 is 0.75. 6 divided by 8 is 0.75. So these two ratios have the same value, 0.75 if you want to express it that way. So that's all a proportion is. It's an equation where ratios are on both sides, and these ratios have the same value. They mean the same thing. So here's an example of one. Now that's not that interesting because there's nothing to figure out here, right? 3/4 equals 6/8. You've known that for a while. Well, it gets more interesting when there's some unknowns. Like maybe 3/4 is equal to 2 times some number over 8. Well, what this equal sign is allowing us to do is we know that the ratio, or the value of 3 divided by 4 has to be the same value as 2x divided by 8. So we can use that to solve the problem. First, let's back up though. Look what happens when you cross multiply. I need a color. Let's see. I don't know. Let's see. That's not gonna work. Okay. Let's go with my boring dark color. I just worry it's hard to see. Okay, let's. How about that? Is that better? Okay. 3 times 8 is 24. 4 times 6 is 24, right? That's another way to test they have the same value. You just cross multiply. So 4 times 6 is 24, 3 times 8 is 24. So you can use that fact to solve for proportions. I can cross multiply. 3 times 8 is equal to 4 times 2x. Right? So then I can play around with this. 3 times 8 is 24. 4 times 2 is 8. So this is 8x. So 24 equals 8x. I could divide both sides by 8 to figure out what x has to be. So these 8's cancel out. 24 divided by 8 is 3. So I've solved that this unknown is 3. That's 3. Which you knew already. 3/4 is equivalent to 6/8. Well, 3/4 is equal to 2 times 3 over 8. And actually, if you want to look at it, little side note, if you multiply, and this goes back to when you were needing a common denominator, when you're adding and subtracting fractions, what'd you do? If you wanted to add 3/4 to something out of 8, what'd you do to it? Well, you multiplied the denominator and numerator by 2 each one by 2, because 4 times 2 is 8, and then 3 times 2 is 6, right? So you're scaling this ratio up by a factor of 2, right? So or scaling each number up by a factor of 2, the numerator and the denominator, so that the ratio remains the same, or the value of it remains the same. Okay, so that's what's going on here. So you can use these facts to solve for more complicated stuff. And why would you need to know that? Well, later on in geometry, you might get something like this. I've got two similar triangles, which means they're proportional to each other. So the proportion of so the ratio of this side to this side, for example, would be equivalent to the ratio of this side to this side. That's what the fact that they're similar triangles says for us. So if all I know about this side is that it's equal to 5x plus 2, I could set up a proportion and solve for that x and figure out what the side length is. So that you'll see those kinds of situations. So let's try one. Okay. How about this one? I need darker color again. Okay. So let's cross multiply. 5 times 63 is equal to 7x times 5x. Now you'll notice that this side will equal 7 times 5 is 35, x times x is x squared. If you don't want to deal with something x squared, you could cross out. Well, forget it. Let's just keep going with it. What you can do is you can see if there's something on top and something on bottom, they would actually cross out. So this you could just look at it as 7 times 5. But we could keep going the way it is. 5 times 63, let's just save some time. 5 times 63 is whatever, 315. 315. Now I want to solve for x. So first, let's get rid of it, of this 35. It's being multiplied by 35. So it's kind of going off the screen here. So 315 divided by 35 is 9. So 9 equals x squared. So to get x by itself, I could square root both sides, or I could just look at it this way. What squared is 9? 3 squared is 9. So x equals 3. Oops. X equals some crazy shape that came out of nowhere. X equals 3. So I cross multiply. So I know that 5 times 63 is equal to 7x times 5x. Yeah? Alright, let's try a real doozy. And just kind of go out with a bang here. Let me move this up here. This is just mayhem. Oh well. Hello. Alright, so 2x plus 8 over 5 is equivalent to, or has the same value as 10x minus 14 over 10. This looks crazy, right? But let's just follow the steps. We cross multiply and set those equal to each other. So 2x plus 8 times 10, or I'm gonna write it like this: 10 times 2x plus 8 is equal to 5 times 10x minus 14. Now we can make this easier on ourselves. Let's divide both sides by 5. Okay, you can do whatever you want as long as you do it to both sides of the equation. So 10 divided by 5 is 2. So this becomes 2 times 2x plus 8. 5 divided by 5 is 1, so that's gone. So this just is 10x minus 14. Now we need to distribute this. What we wanted to do is get x by itself on one side of the equation, and you know, x is kind of caught up in these parentheses. It's being multiplied. Like, there's just so much going on with x. We need to kind of unravel it first. So we're going to distribute this 2 first. So 2 times 2x is 4x plus 2 times 8 is 16. So looking a little better. 4x plus 16 is equal to 10x minus 14. Let's get the x's on the same side. You can choose whatever side you want. I don't want to get into negative numbers if I can avoid it, so I'm going to subtract 4x from both sides. So that's effectively moving this 4x over to the right side. So I can do 10x minus 4x instead of 4x minus 10x. You know, I don't know. I just want to avoid a negative number, I guess. So these are gone. So 16 equals, now 10x minus 4x is 6x minus 14. Okay, now 14 is being subtracted from 6x, so we're going to add 14. So 16 plus 14 is 30. So what's left on this side? 6x, so 30 equals 6x. Um, let's write it up here. 30 equals 6x. X is almost by itself, but it's attached to the 6, so let's get rid of that. Divide that out. 6 divided by 6 is 1, so that's gone. 1 times x is x. 30 divided by 6 is 5. Boom. X is equal to 5. All from this craziness up here. But because we knew these ratios were equivalent, we use that fact to cross multiply and set up a nice little equation where the variables on both sides of the equation, we just move stuff around to get x on the same side. We isolated x, and finally, at the end of the day, x was equal to 5. So, yeah, that's it. All right, have fun.